See, the earlier chapter on statistical methods was telling us to do some calculations. But as we discussed, we have to slowly move towards making conclusions based on the calculation. So, the probability is something which expresses those calculations in terms of some percentage forms, right? Because probability is nothing but using the historical calculations or using some historical information I have, I'm making some kind of interpretation saying what is the chance of something to occur. Probability, or when we use the word probably also, we say the same. It's a chance of something occurring. So I have observed the historical data. In the historical data, probably there were 20 times when the returns were positive out of 50 days. So 40% was the number of days, 20 out of 50. 40% was the number of days where the returns are positive. Now, can I make some kind of an interpretation saying, even in the future, the chance of me becoming profitable is around 40%. So, that is where we are using the concepts of probability. Using historical information, deriving some kind of numbers for the future. So that is where we are calling, we are talking about probability, right? So most of the times we use it in the sense, okay, there is a 20% chance that the price will go up, 80% chance that the price will go down. For those kind of typical calculations is what we use the probability for. And where are those coming from? Probably from our historical observations. How do I say? There are different ways I can say. One, I can say based on the past. Yeah, in the past I have observed that 20% of the times it has gone up and 80% of the times it has gone down. So I may say that in the future also there is a 20% chance of up or down. Or someone else may say, no, past was completely different from the future. I feel there is a 50-50 chance for the future. So probability is nothing but a chance of something happening. And there are different ways in which you can define the probability, right? In simplistic sense, we are talking about the chance, which means we are moving away from the historical. In the earlier chapter, everything was on the historical data, calculations on the historical data. But now we are making a shift. Based on that information, can I use it for my future? The probability is talking about the chance of occurring in future, the chance of occurring or not occurring of some kind of an event. So that is where we talk about something called a random variable to start with, because anything where the outcome is uncertain, we call it as random, right? Tomorrow's stock price, up, down, it's uncertain. That I will call it as a random variable. And that random variable can have any number of outcomes. It can be, at least in this example, it is primarily like up or down or no change. But if I say my percentage change in price compared to today, tomorrow's percentage change in price compared to today, then it can take any value, 1%, 1.1%, 1.45%, minus 1.23%, whatever it is. These are the various values which a random variable can take. Random variable is something whose output I don't know. It comes through chance. Any outcome can come on a random basis or on a some specific, there is a randomness associated with the outcome. So you can think of anything to talk about the future, we can call it as a random variable, because we unless we are fully sure that this is what will occur, otherwise we are calling it as a random variable. The values which it can take are all called as the outcomes. Multiple, any value that it can take are called your outcomes. And sometimes what we might be interested in is some specific outcome or a series of outcomes which I want to track out of them. Like positive, negative, up, down kind of up, down kind of outcome. I want to track only the up. What is the chance that something goes up? I want to track only the up part. So those are what I consider as my events. A group of probability, a group of outcomes which I would like to track. Out of the total set of outcomes, something which I would like to track for future purpose, for decision purpose, I'm calling them as the events. Now, within that event, so as I said, up, down, only if I want, they are the outcomes. If I want to track only the up, then up, the probability of going up is what is of my interest to me, but not the down. The chance of going up is more interest to me, not that of the down. So, in that, before we do the computation, we talk about couple of types of events. Mutually exclusive. When I say two events are mutually exclusive, if one occurs, the other cannot occur. If an up occurs on a particular day, down cannot occur, or vice versa. So those kind of events, we are calling them as mutually exclusive. And when I say exhaustive, at least one of them will definitely have to occur. Right? If I combine all those events, it should talk about the whole space. All outcomes should be included. If I say up and down, these two are mutually exclusive. And if I say these two are exhaustive, I don't say these two are exhaustive, because apart from up and down, no change also could be there. Right? If I combine up and down, all days of up, all days of down, it does not give me the total number of days. Probably there could be some days where there is no change. But if I combine all these three events, then I may say they are mutually exclusive. All three are mutually exclusive. If one occurs, the other don't occur. And all three are exhaustive also. This is something which we very much use in probability world. We are more interested in those kind of events which are mutually exclusive as well as collectively exhaustive. Collectively exhaustive, not in isolation. If I combine all the events, at least every outcome should be a part of at least one of that event. If I say, let's say throwing a dice, getting an even number is one event, getting an odd number is another event. Mutually exclusive, but even when I combine them, they are exhaustive also. I cannot get any other number apart from even and odd. But if I say event A is getting an even number, but event B is getting a number greater than 4, they are not mutually exclusive, because there, if one occurs, if an even number occurs, there is a good chance that it might be greater than 4 also. And coming to mutually exhaustive, if I combine these two events, it's not the whole space. 1 is not covered in any of them. 3 is not covered in any of them. So all possible outcomes are not covered in the combination of the two events. Then we don't call them as exhaustive. Otherwise we are calling as exhaustive. The reason why we talk about is, if I have to make some prediction, if I have to make some conclusion about a particular stock price moving up or moving down, I need to know first of all how many outcomes are possible. Out of them, I want to see what is the one which I would like to track. Without knowing how many outcomes are possible, which is that exhaustive set of outcomes, without knowing how many outcomes are possible, I cannot track how many I want to track. Right? So that's the reason whenever we define the probability also, we say out of the total number of outcomes, how many are the ones which I am tracking? How many of them are favorable to me? So when I am looking at number of up days and down days, what is the probability that the price will go up tomorrow? If I am just observing the data and making a conclusion, the simple thing I am making is, okay, I have observed last 50 days of data. Out of that 20 days there is an up, 5 days there is no movement, 25 days there is a down. So if I want to use that data as an information for the future, I will say the probability of going up is nothing but 20 out of 50, saying 40% chance. That's so unless I know all the up, all the no change, all the down, I cannot make conclusion about the chance of something occurring in future. So we need a mutually exclusive and exhaustive set of events to define our probabilities in a very effective manner. So something, because we always talk about number of favorable to the total number, we always say that it lies between 0 and 1, and all probabilities put together for all the exhaustive events, it sums up to 1. Now, there are 3 ways people define probability. One, as I said, I observe the past data, just the example which I have given, 50 days, 20 days up. So observe the past data, and then based on the past data, take your percentages, which is nothing but a relative frequency in the stats which we have done. You take the relative frequency of each of the classes. Here the class is up, down, no change. For each of the classes, you find out your relative frequencies, and that's how you are finding out the probability. So you are not making any subjective guess or something. You are primarily looking at the past data and you are computing your probabilities, which is what is called as the empirical. Wherever you are talking about number of favorable by number, total number, by observing your past data, that kind of probability which you are giving is called as an empirical probability, which if we are working with samples, most of the times we would be using the empirical probability model itself. Right? Then, if I compute the probability, computation of the probability is still the same. Number of favorable events by the total number of outcomes. But the different ways. When I observe it from the past and I make some kind of a number between 0 and 1 and I calculate, we call it as empirical. Sometimes I won't do any calculations, I'll use a simple logic. Like, there are 50 stocks on NSE. I want to pull up one stock at random. Any of the 50 can come out. Right? Or what is the chance that I pick up an IT stock when I pull out a stock randomly from NSE, Nifty? There are 50 possible outcomes. Any out of the 50 I can pick. And out of that, let's say the IT stocks are some 7 or 8. 8, let's say. Now, 8 of them are favorable to me. So the probability of picking an IT stock from a Nifty 50 is nothing but 8 by 50. Here I did not observe any past data. I am using some common sense. I am using some logic. All of them have equal chance of being picked up. So 8 of them are more favorable, is what are of interest to me. There are 8 ways of picking up an IT stock. Probably if you look at it, there are 8 ways of picking one IT stock. So 8 out of the total number of outcomes is what we are calling as the probability. Here we are not using any observation of the past data. No one has picked up a stock at random, and we have not tabulated that, and we are not observing the past data and pulling out. We are using simple common sense to attach a probability to it. That is what we call as a priori probability, where it's more of a general logic, formal reasoning kind of stuff. Number of ways in which the event can occur divided by the total number of outcomes. And finally, there is a third mechanism to probability called as your subjective, wherein no calculation, no reasoning. I'm using my past experience, my opinion in terms of saying, yeah, this is the chance. Probably if I ask an expert, what is the chance that the interest rates will go up in the next year? Right? He does not use his past data, or he may or may not use. But if he does not use the past data, if he uses just his common, if he is not even using a logic or a framework, but just out of his gut feel, saying, yeah, there is a 70% chance that the interest rates will go up next year. That is where we are calling as subjective probability. Sometimes we use that for our exam clearance also. Right? What is the chance that you clear a particular exam? Sometimes we use the word 50-50. Did we use any empirical data there? Which means if you had used empirical data, probably out of 100 exams which you have written in your life, you should have failed in 50 of them. That is where you will use 50-50 as empirical, using the empirical approach. Did you use any logical reasoning? If you are using a logical reasoning, then probably there should be an equal chance of passing as well as failing, which also may or may not be supported for you in most of the cases. So you are using your gut feel, saying that the chances are 50-50. So some kind of a decision which you are taking based on your experience, based on your opinion, based on how you are perceiving, you are making a probability calculation. That is what we are calling as a subjective probability definition. So any of them, at the end, the use for me is they will help me in creating portfolios. They will help me in creating the return, in estimating the returns which I would be getting, in estimating the risk which I would be taking, because everything in finance is about future. There is nothing of the past when we use the word finance. I invest today. How much will I get in future? So everything we are talking about in the futuristic, in the uncertainistic kind of situations itself. Whatever is the space you are operating in, investment, risk management, whatever is the space we are talking of, I am investing, I am putting my money something today. How much will I get in future, which is nothing assured. So because nothing is assured, we have to look at the probabilities of it getting achieved. So that is where this entire world of stats and probability is getting linked into the finance world, because everything is to do with the uncertainty space itself. So the same probability sometimes people talk of in terms of odds, the betting kind of scenarios, right? Probably when I say a probability is 1/4, sometimes we express this in terms of the odds for as well as odds against that particular event, which is nothing but, so out of 4 chances, 4 outcomes, 1 is favorable, right? That is what is the definition here. Out of the 4 outcomes, 1 is favorable, which means 3 are unfavorable. So the odds for will simply go as 1:3. The favorable is to unfavorable. Odds against is nothing but unfavorable is to favorable. So sometimes from our exam standpoint, he may give the probability and ask us to find out the odds, or sometimes he may give the odds for or odds against and ask us to find out the probability. So if he is giving the probability or odds for is 1:4, I can very well say that the probability of occurrence of that is 1/5, and the probability of non-occurrence of that is 4/5. This is one more way to define probability, and sometimes people don't define something in the terms of probability, if we see the betting meters and all in various places, people don't talk in terms of probability. People talk in terms of odds. The most of the betting games and all, they happen in terms of odds. 1 is to 5, 1 is to 10. These are the typical names we hear of, which is nothing but the odds in favor are 1 against are 10. So the probability of occurrence is as good as 1 by 11, or not occurrence is 10 by 11. Right? So most of the, even for most of the matches and all also, they don't talk in terms of probability. They always put the numbers in terms of odds. But as an analyst, we can very well convert the odds into probability using this small change, because these are the number of things that go in favor, number of units that go against. Probability is 1 by total of them. Now when we talk about the probability, again there are two things which we talk of. One is conditional, two is unconditional. When I look at the occurrence of one event in its isolation, occurrence of one event in isolation, we call it as unconditional probability. I am not looking at it with respect to anything else. Whereas in some cases what we end up doing is, we try to find out the chance of occurrence of one event given something else has occurred. Probably given today there is an increase in the price, what is the chance that tomorrow the price will go up? Given that today there is an increase in the price, what is the chance tomorrow the price will go up? If tomorrow's price is dependent on today's price, then the probability could be different. If tomorrow's price is not dependent on today's price at all, then probably it's as good as find out the probability in isolation itself. So that is where we talk about the conditional versus unconditional probability. Another better example for you is, let's say there are 50 stocks in NSE, right? Let's assume that 8 of them are IT stocks. What is the probability of picking an IT stock? 8 by 50. Now assume that the first stock which I have picked up is an IT stock. What is the probability that the second stock which I am picking up is an IT stock? The second stock which I am picking up, what is the probability that it is an IT stock? Again, here the information that is required for me is, can I take the same stock again? Or is it, I should not take the same stock, which means is it replaced back or is it not replaced back? If it is replaced back, then probably again any 8 out of the 50 can be taken. But if it is not replaced, only 7 IT stocks are there and total stocks are only 49. So the probability of picking up an IT stock now is only 7 by 49. Now depends on, if the question is, what is the probability that a second stock which you are picking up is an IT stock? Now for that I need to know what is the first stock that has been picked up. If it is an IT stock, then probably 7 by 49 is the probability. If it is not an IT stock, then 8 by 49 would be the probability. So what is happening? The probability of picking up is dependent on some other event happening. That place we call as conditional probability. For example, let's say, what is the chance of throwing a 5 in the second attempt, given the first attempt was a 1? No relationship, right? Whatever you have thrown in the first case, it hardly matters. Second case, any of the 6 can fall. 1, 2, 3, 4, 5, 6. It's nowhere dependent on your first throw. So in that case, we don't need to talk about conditional probability because it is nowhere dependent on the previous event. Whereas this picking up a stock kind of an example, if I say I'm not replacing the stocks, which means if I'm picking up one, what is the chance that that one is an IT stock or a non-IT stock? If it is an IT stock, the probability is 7 by 49. If it is non-IT stock, the next probability will be 8 by 49. Right? Only one stock is picked. I want to know what is the chance that the second one is an IT or a non-IT. So wherever we are talking about the dependency on one more event, we are assigning the conditional probability to it. And the conditional probability, if the conditional probability generally represented by A given B, which means what is the chance of A occurring given B has already occurred. Very much useful thing, because let's say I want to predict what is the chance of I making a profit given the economy is good. Right? I may make a profit. The chance of I making a profit in a good economy is always higher compared to I making a profit in a poor economy. It's not that I will make a loss there, but the chances are lesser. Right? So that is where conditional probability will play a role. Whenever we talk about some event happening subjected to something else occurring, right? We talk about that, right? What is the chance that I'll score more than 80 given that I can easily score 60? Without knowing that information, probably the chance of scoring 80 is much difficult. But if I say scoring 60 is already scored, then the chance of scoring an 80 is slightly more easier compared to having no information and starting from the scratch at zero itself. So that is where whenever we are talking about occurrence of one event based on the other event has already occurred, we are assigning the conditional probability. So the simple way that we are using it to calculate is we take it as the probability of both A and B occurring, which is represented by the intersection, divided by the probability of B. So which means I am looking at now reducing the space. What is the chance of B occurring? Only this is the scope that B will occur. Out of this scope, what is the chance that A also will occur? If this is the chance A also will occur along with B, then this divided by the chance of occurrence of B is what is the conditional probability. Given B has occurred, what is the chance of occurrence of A? And if I see that there is no dependency between the two events, especially when P of A given B, it works out to P of A only, which means there is no dependency between B and A. Whether B has occurred, whatever is the probability associated with B, I am finding out only probability of A. Then we are calling those two events as independent events, right? Especially when I am talking about throwing a dice or tossing a coin. The chance of occurrence of a head in the second event is nowhere dependent on what I got in the first toss. They are all independent kind of events. In that case, even if there is a conditional probability, it will be equal to the unconditional or marginal probability itself. Right? Now, how do I use that? Typically, we don't work with one event. Right? When we are taking up the data, what is the chance of getting a profit on a particular day? That is one single event. But I want now, in the realistic world, will not work with one event at a time. We'll take multiple events. What is the chance that the economy is good as well as I make a profit? we don't talk about one event at a time. We take multiple events, combine the events, and then talk about making a profit or what would be the situation. So whenever we are talking of two or more events joined together, we are using various rules of joining them. One being your multiplication rule, where we talk about what is the chance of both the events occurring together. What is the chance that which means both economy is good as well as I making a profit. What is the chance of both these things occurring together? That is what we are calling as a joint probability, occurrence of both of them. Both is what is a term that we are using for joint probability. And the rule which we are using for it is what we are calling as a multiplication rule. What we are saying in that multiplication rule, we are simply saying P of A intersection B, which is the occurrence of both of them. Or sometimes people write it as P of AB also, whatever it is. Both of them occurring is nothing but the probability of first one of them occurring into, given that this one has already occurred, what is the chance of the second one occurring, which is nothing but P of B given A. What are we saying here? If I talk about, let's say we have a group consisting CFA as well as FRM guys, right? Now I want to find out how many are taking both of them. What is the typical way I can go? I mean, how is this formula coming out there? First, I'll pick up people who are writing one exam. Either I start with CFA or FRM. So that is A. I start with people who are writing one exam. I make a subset of that. Now, out of these people who are writing CFA, who are writing FRM, that is the set of guys who are writing both of them. Right? Given that this is a group of only CFAs, I can pick out who are writing FRM from this group, and I can say this is the combined. This is the set of people who are writing both of them. That is what this formula is operating of. You take what is the chance of occurring 1. What is the chance that the person is writing a CFA? Given that he is writing CFA, what is the chance that he is writing FRM also? But that is what will give me what is the chance that a person selected is taking both the exams. So it could either go on the other side as P of B multiplied by P of A given B. Both these things do work out to your multiplication rule of probability. And as I said, if the events are independent, if they are independent, what did we say? P of B given A will become P of B only. A is nowhere applicable now. So this multiplication P of A intersection B will become P of A into P of B. So in case of independent events, the joint probability of occurrence of multiple events is nothing but the product of their individual probabilities. P of A into P of B into P of C. It goes like that if all the events are independent, which means what is the chance of getting ahead in all the 5 tosses of the coin? All tosses are independent. So it's as good as 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. The chance of getting ahead in all the tosses. So that's the place where we typically use, because when the tosses are independent, I'm least bothered about what is the chance of occurrence of if I want to find out what is the chance of occurrence of joint occurrence of all the 5 heads, we are simply taking that as a multiplication of the individual probabilities itself. Then we could have scenarios talking about the either or kind of occurrence between the events. What is the chance that either A or B will occur? We don't talk about both of them occurring. We are fine with at least one of them occurring. That is, here either A or B means it includes even the both also occurring. So whenever we talk about, let's say we are talking about events, A being getting okay. So let's say we are talking about A as an event getting even number on the throw of a dice, and B is an event getting greater than 3 on the throw of a dice. What is the commonality? If I say P of A intersection B, what did we say? Probability of A into probability of B given A. What is the probability of A here? A is getting an even number, 1 by 2, 3 by 6. Okay. Now, given A has already occurred, which means given that the outcomes are only 2, 4, 6. Given that A has already occurred, means now I know that the outcomes are only 2, 4, 6. What is the chance that it is greater than 3? 4 and 6 are favorable here. Out of this group of 2, 4, 6, greater than 3 means 4 and 6 are favorable. So 2 out of 3. So this becomes into 2 by 3, which tells me the probabilities of both of them occurring. A number greater than 3 as well as an even number, which are nothing but 4 and 6, the final output. 2 outcomes out of 6, which is what is giving me 1 by 3. But if I go with the formula, it goes like this. Now the question will be, what is the chance of getting either even number or a number greater than 3? So even number is 2, 4, 6. Greater than 3 is 4, 5, 6. Right? So probably except 1 and 3. All the others are there in the list. So 4 favorable outcomes out of the 6, which is giving me the probability of 2 by 3. The same thing if I go with the formula model, because most of the times we cannot use the logic. We may have to resort to the formula itself because the number of possibilities and all could be daunting. So we may have to use the formula approach itself for that. So for that is where we are talking of, okay, P of A. This is the formula I look at. So P of A is the probability of an even number, which is 1 by 2. P of B, probability of getting a number greater than 3, again 1 by 2, 4, 5, 6. And minus probability of A intersection B we got in the above case, which is 1 by 3, which is what is again giving us 2 by 3. Even with the common sense, we are able to say that the outcomes are 2, 4, 6 and 5. 4 outcomes out of the 6, we are calling it as 2 by 3. But addition rule is a generalized kind of a rule, especially if I want to find out the probability of at least one of them occurring. One of the events occurring, if I want to look at it, that is where I am using the addition probability kind of a rule. Here, if my events are mutually exclusive, this will not be there. The joint will not be there. Both of them occurring together. Joint is nothing but both the events occurring together. That will not be there. Because mutually exclusive means if one occurs, the other will not occur. So the joint occurrence is 0. So the addition rule will simply become the sum of the independent probabilities itself. If the two events are mutually exclusive, the probability of any one of them occurring is equal to the sum of their independent individual probabilities. This is one more rule associated with our calculations. But the most important rule for a lot of business decisions is the total probability rule. What it says is, if I consider some events, let's say B1, B2, B3, so on up to Bn. There are some events which I am considering. If I assume that all these are mutually exclusive as well as exhaustive, what could be our possibilities? Let's say we are talking about go up, no change, down. B1, B2, B3. They are mutually exclusive and they are exhaustive. If I assume a set of events are mutually exclusive as well as exhaustive, what it says is, you can find out the probability of anything else, anything which you want. Let's say I want to find out the probability of some A. I want to find out the probability of some A using these things. The way it is found out is, you find out the probability of A given B1, multiply it with probability of B1. Similarly, probability of A given B2, multiply it with probability of B2. So like that, the whole list, probability of A given B3 multiplied by probability of B3 and so on up to Bn. What it is saying, this will be applicable only if my B1, B2, B3 and so on, whatever I am considering, they are mutually exclusive and exhaustive events. This is a very solid rule forming the foundation for what is called as the Bayes theorem, from which huge number of conclusions are very easily derived. All it is telling us is, if B1, B2, B3 are mutually exclusive, like the example as I am saying, economy, good, moderate, bad. Let's say if I am talking about these three, good, moderate, bad. These three are mutually exclusive as well as independent, exhaustive, mutually exclusive as well as exhaustive kind of events. Now if I want to find out the probability of unemployment, what it says is, I can combine it with those mutually exclusive and exhaustive events, saying what is the probability of good economy multiplied by what is the probability of unemployment in a good economy. What is the probability of moderate economy multiplied by what is the probability of unemployment in a moderate economy. Probability of bad economy multiplied by probability of unemployment in a bad economy. It's like a weighted average. You weigh it based on the probabilities and take the probabilities of that particular event, assuming this particular condition. So when you are arriving at such kind of calculation, we are finally arriving at the probability of A, probability of unemployment in total, which is an unconditional probability we are trying to find out using the various conditional probabilities. That is what is being talked about by a total probability kind of a rule. Mostly in calculation relating to Bayes theorem and all, we will be using this total probability rule very heavily. Right? Okay, let's take up. Okay, I think a couple of numericals are there. So the same logic will be applicable even if I want to find out the expected value also. What is the chance? So what is the probability that an economy is good multiplied by what is the chance of making a profit in a good economy? How much profit can be made in a good economy? What is the chance that the economy is moderate? multiplied by how much profit can be made in a moderate economy. So that is what will tell me what is my overall chances of making a profit. Because I don't know anything about whether the economy will be good or bad or moderate. But if it is good, this is the chance. If it is moderate, this is the chance. If it is bad, this is the chance. And the chance of being good, moderate, bad is this. Based on that, I am computing what is the chance of making a profit in my case. Once we compute the mean, expected value is nothing but the average. We have seen how we can compute the variance and all those things, because variance is nothing but every value we subtract from the mean, square it and take the average. That is what we called as the variance. So once we have the mean, we can compute the variance, we can compute the skewness, all the kinds of stuff. So what we will do is we'll take up a couple of numericals which can help us in solving all these questions and get comfortable on this. So let's look at a few of them. There is a 30% chance that the economy will be good next year, 70 that it will be bad. So these are mutually exclusive, exhaustive. 30% good, 70% bad. So there is nothing called moderate in this case, because it is forming the whole 100%. Okay. So how do I write it in the probability language? We should develop the art of writing these things in a probability language. So there is a 30% of good economy, and there is a 70% of bad economy. Okay. If the economy is good, there is a 60% chance of bull market. How do I write this? Probability of bull given good. In a good economy, the chances of making a profit is 60%. And 30% of a normal market. So probability of normal given good economy is 30%, and 10% of a bear market. Now these three again are mutually exclusive, because 60, 30, 10. Okay. If the economy is bad, there is a 10% chance of a bull market. Bull given bad is 10%. Then probability of normal given bad is 30%. And the probability of bear given bad is 60%. Now what do I want? What is the joint probability of a bad economy and a bear market? Bad economy and a bear market. How do I find this out? 70 into probability of bad into probability of bear given bad. This is what we can write. What is the probability of bad for us? Probability of bad is 70. Probability of bear given bad is 60, which is what is working out to 42%. So sometimes we can use common sense also, but if we are using more of a formula based approach, it gives us more and more clarity also. Now if I ask you, what is the probability of a bull market next year? This is an important one. What is the probability of bull market next year? This is where total probability rule will be helpful. I want probability of bull. Probability of bull given good, because good and bad are mutually exclusive and exhaustive. So I can write them. So just like using the total probability rule, I can write probability of bull given good into probability of good plus probability of bull given bad into probability of bad. So what is bull given good? Bull given good is 60, probability of good is 30. So there is 18%. Probability of bull given bad is 10 into probability of bad is 70. 7%. So total it is 25% or 0.25. So the chance, so this is where your total probability rule will be helpful. He's asking what is the chance of a bull market, but he did not he gave bull market with respect to some economy. In a good economy, this is the chance of bull. So he has given conditional probabilities, but he did not give any unconditional probability for us. Right? Using the total probability rule, if at all the G and B are mutually exclusive and exhaustive, I can find out the probability of anything else using the conditional probabilities of these things. That is one important rule for us to derive the probabilities of. So for a bull market, even though the information is not direct, using this total probability rule, we can very well arrive at that kind of a figure. Fine. Okay, now look at the next one. Parking lot, 100 red cars. This is a very simple one. 100 red and blue cars. 40% cars are red, 70% have radios. 70% of the red cars have radios. 80% of the blue cars have radios. So here, how do we write it here? %40 of the cars are red. Probability of red is 40%. Probability of blue is 60%. 70% of the red cars have radios. Probability of radio given red, right, is 70%. Probability of radio given blue is 80%. Now you talk about. Very easy. I mean, sometimes even with common sense you can do it, right, by classifying the numbers. Okay, 100 cars, 40% of the cars are red. So 40 is red, 60 is blue. Some questions, it will not be that difficult to do it with common sense. But if you practice on the problems, even if some complex is given, we would be able to use the formula to derive the answer for us. Right? Okay. Now, what is the probability of selecting a car at a random, having it be red and a radio? What is the probability that it is red and it has a radio in it? Red and a radio, right? Intersection, which is nothing but probability of red into probability of radio given red. So 40% into 70%, 28%. Right? So it doesn't create any confusion for us, especially if we master the art of solving it through the formulas route. Or at least even the formula will get revised so many times. Though you can use your common sense, formula gets revised so many times, and even if some complex is being given, you would be able to address it comfortably. What is the probability of selecting a car that is either red or has a radio? Which is nothing but probability of red, addition rule, right? Probability of red plus probability of radio minus probability of red and radio. Red and radio we have already talked about, 28%. So probability of red is 40. 40 plus probability of radio. Now you tell me, how do you find out probability of radio? Minus 28. How do I get the probability of radio here? How much? 48 plus 28. Probability of radio, again, I can do it with their conditional probabilities because red and blue are mutually exclusive and exhaustive. So probability of radio, I can get it as probability of radio given red into probability of red plus probability of radio given blue into probability of blue, which is working out to 76%. So I can put here 40% plus 76% minus 28%. So probably whatever it comes out, that is the probability that a car will be either red or a radio. What is the probability that a car is red given that you already know that it has a radio? Which means you are finding out probability of a red car given a radio. Again, using the conditional probability, red and radio divided by probability of radio. You have computed the probability of radio in the earlier case by using the total probability rule. Red and radio also we have computed in the earlier case, which is 40 into 70, which is 28%. So doing these two, you are getting. So once you make these calculations, one or two, that too getting comfort with the multiplication rule of probability, addition rule and the total probability rule, we can easily solve the question. Because most of the time the problem that comes out is, we by default assume that they are independent and we do the multiplication of the probability. But there is a lot of conditional probabilities given in the question. So we have to be very careful while using the conditional probabilities. So if at all, only if all the events are mutually exclusive and exhaustive, then I can find the unconditional probability of any other event using the conditional probabilities of both the events. Okay, then look at the next one. Just some level of practice will put you very comfortable there. 50% chance that the Fed will cut the interest rates tomorrow. Probability of cut is 50%. On any day, there is a 67% chance that the DJIA will increase. So, on the days the Fed cuts, the probability that the DJIA will increase. So, I can write it as probability of DJIA increase given cut is 90%. What is the probability that tomorrow the Fed will cut the interest rates or the DJIA will go up? Which means probability of cut or DJIA. So it is going with probability of C, which is already known, probability of D, which is already known, minus probability of C intersection D. How do I get C intersection D? I multiply these two, I get that. Probability of C into probability of D given C. I multiply these two, I will get C intersection D using the joint probability rule or multiplication probability rule. You substitute this there, you will get probability of C union D. Yeah. An investor is considering the purchase 30%. That something will be acquired in the next 2 months. So, okay, probability of acquiring is 30. So, probability of not acquired is 70. If ACQ is acquired, 40% probability of earning 30% return on investment and a 60% probability of earning 25%. Right? So if it is acquired, what is my interest? How much am I getting? What is the earning for me? If it is acquired, there is a 40% chance of earning 30% and 60% chance of earning 25%. So what is the expected value there, 40% into 30% plus 60% into 25%, which is around 15 and 12, 27%, which is around 27%. In case of acquisition, my earnings are going to be 27%. In case of acquisition, my earnings are going to be 27%. And what is it saying? If it is not acquired, the expected return is 12%. Okay, so probability of the earning given not acquired, that is 12%. What is the expected return on this investment? So what is that? I need to find E. So as I said, E given A into P of A plus E given NA into P of NA. You can very well do that. So there is a 30% chance of getting 27% and 70% chance of getting 12%. So again a weighted average is what will give you what is your expected return in the scenario. So that is where you use these kind of calculations. This is a very big application in the finance world. What is your expected return on the investment? That is purely depend on how the economy is moving in the future. And how the economy will move, different people will have different expectations out of it. Different probabilities are given either through their basic judgment of the past data or through a subjective kind of a model, whatever it is. People have different ways of defining the probability, and based on that, we can compute what is the expected return that we are going to get out of the investment. The same way, even the next one can also be looked at. Then, the next aspect which we talk about here is, in case of two events, if they are not independent, there is some level of dependency between them, right? That two different variables, if I am considering, let's say one variable being Infosys stock, the other variable being the Sensex. With these two variables, there is a possibility that both of them may be moving together. If let's say the Sensex is up, the Infosys stock is also up, or vice versa, or they may move in opposite directions, or there is no relationship between them at all. So if I want to try to understand these aspects, we are resorting to an item called covariance as well as correlation. When we are trying out what is the deviation from the center, we used variance. What is the dispersion from the center? We have used variance. But if I want to see the joint dispersion from the centers of both of them together as a pair, I want to see the dispersion from the center, I am calling it as covariance. If I take only one variable, let's say Infosys stock returns, I take only that one single variable and find out the deviation from the center, we call that deviation as variance. The difference and then the square, we called it as a variance and the standard deviation. But if I want the deviation from the center of a pair, Infosys as well as Sensex together, when I am finding out that difference from their corresponding centers, we are calling it as covariance. And here, because we are not squaring it, right, we are taking the difference from the centers for both of them. So the net could be positive or negative. If the net is positive, we are saying that both of them are moving together. If this is up, this is up. Both are positive only means the multiplication will be positive. Or both are negative also means the multiplication is positive, which means both of them are moving together. Both of them are having the same sign. But if the net is the negative, it means that both of them are moving in the opposite direction. One is positive, the other one is negative kind of stuff. So that is what is being mentioned by covariance, just like the way we did for our variance, right? Especially if with the data, if I want to do, if I have another set of data, let's say, if I say I have another set of data like this as a pair, I want to see if there is any relationship between these two as a pair, right? What I will do, I will take the difference of each of these things from their mean, and correspondingly I'll take the difference of these things with its own mean, and see if this is above the mean, is this also above the mean? This is below the mean, even this is also below the mean. Only in that case, we are saying that both of them are moving together. Otherwise, both of them are moving away from each other. Otherwise, no movement at all. So it's as good as saying, let's say I'm finding out the mean of both of them. The mean of both of them. Okay, I'm finding out the mean of both. I'm trying to find out the deviation of each of them with their multiplied by the pairwise, the deviation of this from this mean. The pairwise I am trying to find out, and I do this exercise on a pairwise basis. This is the difference or deviation on a pairwise basis, and what I can very well say is, whatever the average I am getting out of this, I call it as covariance. The average whatever I am getting out of this, I am calling it as covariance. So 25 point something is the covariance here. Because it is positive, we will say that both A and B are moving in the same direction. But how strongly? Are they very strongly moving in the same direction or very weakly moving in the same direction? The strength, or the other way of asking is 25.53 very high or very low? There is no meaning to that. Covariance as a magnitude has no importance. Only the sign is what we take from a covariance, right? So if I want to know whether it is high or low, all we are doing is the covariance, whatever we have got, we divide it by the product of their individual standard deviations. The covariance we divide by the product of their individual standard deviations, and that is what we call as correlation. So correlation and covariance definitely will have the same sign, because standard deviations are always positive quantities. Covariance divided by the product of the standard deviations, the sign will be the same whether it is positive or negative, right? But this will talk about the strength, because it's a kind of a normalization wherein the value will lie only between -1 and +1, right? The value will lie only between -1 and +1. So if it is close to +1, we'll say it's a very strong relationship. If it is away from +1 and probably close to 0 on the positive side, we say it's a very weak relationship. The same thing we will apply for the negative side, right? So here also we are doing the same. Let's say if this number, let's say this number divided by, I'm just taking the standard deviation directly. Standard deviation of the first one multiplied by the standard deviation of the second one. So this is giving me a number like 0.11, not close to 1, but very much close to 0. Though it is positive, it is very much close to 0. So we may say that the relationship between these two is very, very weak, right? So that is how we interpret the relationship between the two variables. Covariance, we can't make out whether it is high or low by looking at that 25. So it's only the direction that helps us. So simple logic is all the values are compared with their corresponding means on a pairwise basis, and the net is what is found out. Net average is what is typically found out. And if that is positive, we say that the relationship between the two is positive, otherwise the relationship between the two is negative. Now, when it comes to the probability case, that was the case where absolute numbers are given. But in case of numbers, if the probabilities are given means only frequencies are given, relative frequencies are given. That is what is the difference. If in the question, instead of giving the absolute numbers and asking us to find out the probability and asking us to find out the covariance, if he gives us more in terms of the probabilities itself. Let's say look at this question. X equal to 2, y equal to 10. The probability is 0.3. X equal to 6, y equal to 2.5. The probability is 0.4. And something like this. X equal to 10, y equal to 0. The probability is 0.3. So how do we rewrite this? I can very well try to rearrange this saying, okay, there are three probabilities we are talking of, 0.3, 0.4, 0.3. And I will write this as x, y. What is my x here? 2. My y is 10. My x is 6. Y is 2.5. My x is 10. Y is 0. If I rewrite the same into this form of a table, it becomes very easy for me to solve this problem. Now I'll take one comprehensive problem, the same thing which was given in the earlier case, the probabilities, the returns on A, returns on B. Now using this information, I want to find out the mean, the variance, the standard deviation, the correlation, covariance, all in one single numerical. Now, probably let me take this into the spreadsheet, easy for us to calculate without struggling too much. 20, 50, 30. And when it comes to A, 18, 11, 17. 19, 14 and 9. Okay, let's look at this relation now. So probably it's like there is a 20% chance of getting 18% a good economy, or probably you can talk about it as economy, and returns on A, and returns on some X, and returns on some Y. There is a 20% chance that the economy will be good. And in that case, A will give me 18%, X will give me 18% return, and Y will give me 19% return. Like that you can very well associate. And now, if I want to find out the expected return of X, I am trying to do all the calculations which can typically be asked. How do I get the expected return on X? 20% into 18% plus 50% into 11% plus, that's a weighted average. That is what will give me the expected value of X. So 20% into 18%, 50% into 7%, something like that, which is working out to 11.2%. The expected return on X is 11.2%. Okay, then what is the expected return on Y? The same logic I can use. Right, 20% into 19% plus 50% into 14% kind of stuff. Okay, what is that I am getting in PE? At least the Y, I am seeing, okay, the first conclusion that will come out for me is Y is giving me 13.5% return. So Y is giving more return compared to X. How am I getting these 20, 50, 30? Probably it could be from the past experiences. Right? Out of last 10 years, 2 years were a good economy, 5 years were a moderate economy, and 3 years were a bad economy. So again, if a person is looking for the next 10 years, he is taking those kind of probabilities. And in the good economy, what was the average return which X has given? In a real world, we do it like that. Whereas when it comes to exam, these numbers are straightforward available for us, which means we are considering them directly and trying to find out which ones are good, which ones are not good. Now, how do I find out the variance or standard deviation here? What is the way we are computed the variance in the raw data? Every value, we subtracted the mean, squared it, and after that taken the average. Here also, here the only difference is every value of X, subtract from the mean of X, subtract from the average of X, square it. Up to here, no difference. But after that, multiply it with its corresponding probability. Because in the regular process, we take the average. From the regular data, we take the average because all data have equal weightage. So a simple average will work there. But here the weightages are different, 20%, 50% and 30% kind of stuff. So it's like a weighted average that I have to take, which is nothing but multiply it with its corresponding probability. After you do the subtraction, square, you multiply it with the corresponding probability. You don't need to take the average in the end, because you are multiplying with the corresponding probability itself means you are taking a weighted average of that. So you do this. So once I do this, then I add up these things. This is what will give me the variance of X. The variance of X for me is this much, 1.4%. Right, 1.4% is the variance of X, which means the standard deviation of X for me is the square root of the variance. This is the standard deviation, almost 11.8% is the standard deviation of X. So on an average, X is varying by 11.8%. The returns of X are varying by 11.8%, or the risk in X is 11.8%. Now if I want to find out the same thing for Y, right, this one set of calculation will solve all our questions. Variance of Y, we are talking about Y minus the expectation of Y whole square, multiply it with its corresponding probability. Oh, let me do it here. Y minus the expectation of Y whole squared multiplied by its corresponding probability. So based on that, if I am taking it, from here I will get my variance of Y as a simple summation of these, which is giving me some 1 point, or it is giving me even more lesser, 0.12% is what I am getting. Okay. So from here, if I am trying to find out the standard deviation of Y, which is nothing but the square root of this, the standard deviation of Y is coming out only to around 3.5%. So what it is meaning to us is the risk in Y is much lesser compared to the risk in Y is much lesser compared to that of X. Y is giving more return and less risk. So obviously that is the most preferred choice for me if I am going with choosing one out of the two. It is having less risk measured by standard deviation or the variance. It's having more return. So it is the most preferred kind of a security for me corresponding to the others. Now, how do I find out the covariance and correlation here? For covariance, all you are doing again, X minus its corresponding average multiplied by Y, the pair. We have to take it as pairs. Y minus the corresponding average of Y. We don't do a square here. We just do pairwise multiplication multiplied by its corresponding probability. Because in the regular case, we take a simple average of them. But here we don't take the average because it's like a grouped. 0.2 is nothing but 20% of the data is behaving like this. So we have grouped the data instead of the raw data. So we don't take the average in the true sense. We take it as a weighted average by multiplying with the corresponding probability. This is one thing you have to be comfortable with when you are working out on the problems relating to probability. The same question given in statistics from a raw data versus the same question in probability where a probability is given. The process is still the same. The final averaging process is different. In case of a raw data, you are adding up all and taking an average. If for anything, standard deviation or variance or covariance, for all these things, you are taking the average at the last. But in case of probabilities, you won't take any average at the last. You are multiplying it with its corresponding probability and giving a weighted average here itself. So this is what is my covariance. Okay. So the covariance of Y, X and Y. Covariance between X and Y is the summation of this. This is the covariance between X and Y. And now when I have to talk about the correlation between X and Y, we are only talking about covariance divided by the product of their two standard deviation. This into this. So this is giving me almost 0.316, 31.6% is what is being highlighted as the correlation. So here what it is saying is there is a positive movement. Both of them are moving in the same direction, but not that strongly. If we see here, this has fallen only by 5 units, whereas this has fallen by 7 units. Right here, this has fallen by 5 units, but this has fallen only by 4 units. So it's not a same percentage drop or same percentage increase, and that is where it comes out with the correlation is there, but it is not that strong between the two. So this is how you solve the problems relating to expected values, standard deviations, variances, all these kind of aspects. Right? Then the same logic goes for application to your portfolios. You are investing some proportion of the money in security 1, some proportion in security 2. What is your expected return? What is your variance of returns? These are some of the things that come up as a part of the portfolio calculations. Again, there is also some weightage and the return kind of stuff. So the simple way for us to work out is, in case of returns, it's nothing but it's a simple weighted average. right? If one of them is having a 10% return, the other one is having a 15% return. So probably you look at this calculations again. For the assets A and B, A is giving me 10%, B is giving me 20%. What is the expected return on the portfolio? In which you are investing equal weightage in both of them. So weightages are W1 is 50%, W2 is 50%. The first one is giving a 10% return, the second one is giving a 20% return. So your portfolio return is nothing but a weighted average return, which is 0.5 into 10% plus 0.5 into 20%, which is taking your expected return to 15%. But the problem comes with the variance. Variance, this is what is the whole story behind portfolio management. The variance is not the same as the individual. See, if the return, the expected return is a simple weighted average of the returns. But the variance is not the simple weighted average of the individual variances. The reason being, the relationship between two of them will pull down the overall variance. The diversification comes when you are combining two securities which are having opposite relationship between them, or which are having a weaker relationship between them. Because what do you mean by weaker relationship? If one is going up, the other may go up, may go down, may does not even change also. If I say negative relation, if one is going up, the other is going down. So even if one is losing, the other will gain, and probably my loss is very minimal. So the correlation decides the risk. That is what is the whole funda behind the concept of portfolio management itself. The reason why you are diversifying is the combination will reduce your overall risk, and that too when you choose a combination of two negatively related securities, or probably even if they are positively related, not that strongly related. Because if I'm choosing two strongly related ones, if they are going up, both of them will go up. I'll get a huge profit. But if they are going down, both of them will go down together. I'll lose very heavily. So they don't form a good portfolio. Always choose something which are having a negative relationship, because in reality negative relationship is difficult to find. At least choose a positive relationship which is on a very lower side. And that is where the formula, whatever we are talking about, the variance of the portfolio, apart from weighted average of their individual variances, we give some weight to their covariance or the correlation also, because covariance and correlation are again related. We give a weightage to their covariance also, and that is what we call as the variance of the overall portfolio. In the portfolio management, we'll take up this again with a live data, with a full data set, and see if I combine two securities, their average will be average return, mean return, expected return will be in between the two returns itself. Let's say 10% and 20% are the returns. Any combination I combine them, the expected return of the portfolio will be between 10 and 20% itself. Whereas if their variances are 25 and 36, some combination I combine the two securities, my overall variance can be less than 25 also. Overall variance need not lie between 25 and 36. It can be brought down to less than 25, which means combination is always less riskier compared to any one in isolation. That is the important fundamental that is going behind portfolio management. Again, when we take up the portfolio management, there we'll take up the data and we'll work it out exactly where the number will come down when I combine both the securities A and B. So from this standpoint here, if I want to calculate the variance, It is straightforward for me. I can use the formula, the weighted average. So 50% in the first one. So 50% square into variance of the first plus 50% square into variance of second plus 2 into 50% into 50%. He did not give the covariance. He has given us the correlation. How do I find out covariance here? Correlation equal to covariance by standard deviation of A into standard deviation of B. So covariance is nothing but correlation into standard deviation of A into standard deviation of B. Correct? So probably we know the standard deviation. Correlation he has given as 0.6. Standard deviation of A, I can take it as 50%. Right? Variance is 25%. So the standard deviation is square root of 25%, which is 50%, into the variance of B, which is 60. Standard deviation of B, which is 60%. You use this, whatever the value that you get, we are calling that as the variance of the portfolio. Take a square root of that, we will get the standard deviation of the portfolio. And so whenever we have to compute the variance, this is another major aspect for us. If at all I am talking about an N asset portfolio, I am creating a portfolio with N securities. I need their N returns, N individual variances I require, and also all pairwise covariances are required. So if there are N items, see, if there are 2 items, there is only one pair. But if there are 3 items, AB, AC, BC, 3 pairs are there. Again with 4 the number is increasing. So like that, I require at least N into N minus 1 by 2 such pairs. So if I am talking of 10 items, 10 into 9 by 2, 45 pairs of covariances and correlations I have to find out. That makes the finding out of portfolio variance a very tedious kind of a job. And that is where people use softwares. Probably Excel kind of a tool uses something called solver kind of scenario. Like that, there are so many portfolio management kind of tools that can be used. Just with 10 securities, if I have to compute 45 covariances and correlations on a regular basis, it becomes a very massive task. Right? And normally mutual fund managers and all, they manage at least 40, 50 kind of securities in their portfolio. So again, you can imagine how many covariances and correlations have to be looked at. That is where the spreadsheet kind of tools can help us in finding out the variance of the portfolios in a slightly better manner. But for us, as far as the exam is concerned, we are hardly looking at a 2 asset or a 3 asset at the max. But the formula will still remain the same. W1 squared, sigma 1 squared, W2 squared, sigma 2 squared, W3 squared, sigma 3 squared. 2W1, W2 covariance between 1 and 2. 2W1, W3 covariance between 1 and 3. 2W2, W3 covariance between 2 and 3. Even that much itself is a huge thing. So as long as he is expecting the conceptual understanding, he did not give even the problem of that level of depth also. But in reality, the numbers will be much high in number, and they may change quite drastically also. Now, one more concept in this probability that we are looking at is the Bayes theorem, which is more like I want to update the probability of an event given some other event. So basically it's like this. We have derived slightly some time back P of A given B into P of B is equal to P of A intersection B. This is what we said. And probably the same thing I can write it as P of B given A into P of A also. That also is equal to P of A intersection B only. Now if I try to equate these two terms, P of A given B into P of B is equal to P of B given A into P of A. And from here, it is coming out that P of A given B is equal to P of A by P of B into P of B given A. These two getting equated. Now, what is that we are saying here? If I want to find out the probability of A given some B has already occurred, if I know its reciprocal, probability of B given A has already occurred, and the unconditional probabilities of both the events, I can very well find out the probability of A given B has occurred. That is, so even if we remember the formula, we should be able to solve the problems quite comfortably. Right? P of A given B is nothing but P of A by P of B into P of B given A. If I am able to even remember the formula, the question becomes quite comfortable to be solved. So just let's try out one or two problems which can give us the comfort level. Look at the last one, bonds. Bonds rated B have a 25% chance of default in 5%. C have 40% chance of default. A portfolio consists of 30% B and 70% C. So how do I write all these in probability language? Probability of B is 30%. Probability of C is 70%. Correct? I can also write it as bonds rated B have a 25% chance of default. How do I write it? Probability of default given that it is a B rated bond. So writing it in a probability language is very important for us. Right? This we are saying 25%. And we are also saying bonds rated C have a 40% chance of default. Probability of default given as C is 40%. This is the information we have. Okay, nothing else. So probably, if a randomly selected bond defaults in a 5-year period. Now we got an information that the bond has defaulted. Some bond has defaulted. What is the probability that it was a B-rated bond? So what is that we need to find out? We need to find out probability of B given D. Given that a bond has defaulted, what is the chance that it is a B-rated? That is what we have to find out. We have to find out probability of B given D. Clear? Now use your Bayes theorem, because we have the reciprocal of that in our question. If in the values given, because the reciprocal of that is available, the first thing that gives me as an idea is, why don't I do the Bayes theorem application? So from that, what I can try out, P of B given D according to Bayes theorem is P of B by P of D into P of D given B. Okay, P of D given B is available to me. I can use it. P of B is also available. I can use it. Now, how do I get P of D? How do I get P of D here? Mutually exclusive and exhaustive events. Right? If these are mutually exclusive and exhaustive, I can get the unconditional probability of any by expressing them as their conditional probabilities. P of D given B into P of B plus P of D given C. This is one thing you have to get a clarity on. I can write it like this. So probably all this information is there now. P of D given B is 25 and P of B is 30. So around 7.5%. P of D given C is 40 and P of C is 70, which is 28. So around 35.5% is my P of D. Now I can very well go with it. P of B is 30 by P of D is 35.5 into P of D given B is 25. Based on this, I can make out that if a particular bond has already defaulted, the chance that it comes from B is that much, which means the remaining chance is that it will come from the C rated. Just try the above one then before we move on to the next. John purchased 60% stocks in a portfolio while Andrew purchased the other 40%. Half of, okay, so probability of John is 60. This practice is something required. Probability of Andrew is 40. Other 40%. So mutually exclusive and exhaustive. Right? He said other. If he had just said 40, I may not believe that it is mutually exclusive, or I may not believe that they are exhaustive also. Okay. Half of John's picks are considered good. Given John's pick, the probability that it is good is 50%. While 1/4 of the Andrew stocks are considered to be good. Given an Andrew stock, the probability that it is good is 25%. Okay, if a randomly chosen stock is a good, so it is given that it is good, what is the probability that John selected it? J given G. You have G given J. So directly you can use Bayes theorem. You can think about the Bayes theorem. So probability of J given G for you is nothing but probability of J by probability of G into probability of G given J. G given J is there. Probability of J is there. Only probability of G you don't know. Again, probability of G, you can go with the total probability rule because those two are mutually exclusive and exhaustive event. You can arrive probability of G by expressing them with respect to the conditional probabilities of G and J. Fine. Then finally in this there is one more aspect talking about the counting related rules. See, picking up some stocks out of some number of stocks. I have 10 stocks. I have to take 3 at a time to form a portfolio. In how many ways I can form that? Right? Or I have to take 10 stocks and I have to give ranking to some 3 stocks. In how many ways I can do that? So selecting something out of some set of values with an order like ranking. I'm giving some specific order. We call them to be our permutations. Number of ways of selecting by giving a specific order or a rank. We are calling, so out of 10 items, if I have to select 3 of them, but the order is important. Which one is first, which one is second, which one is third. The order of picking is also important. Then the number of ways in which I can do that is what we are calling as a permutation. And the number of ways we calculate using the formula 10p3, which works out to nothing but 10 factorial divided by 10 minus 3 factorial. So factorial is nothing but a multiplication up to 1, right? And even your calculators, they directly display the value when you are giving 10p3. It gives us the value directly. But even if you want to solve it, it is nothing but 10 factorial by 7 factorial, wherein 10 factorial will go up to 10 into 9 into 8 into 7 up to 1. So overall it is working out to, probably you can write 10 factorial always like 10 into 9 into 8 into 7 factorial. Even the denominator is 7 factorial. So overall you are left only with 10 into 9 into 8. So 720 ways in which you can pick up 3 items out of the 10 items where the order really matters. And if that order really doesn't matter, we call that as combination. Out of 10 stocks, I want to just pick up 3, any 3. I'm not bothered about which one I am picking up first, which one I am picking second, and so on. The order is not important. I want 3 items to be picked up. If that's the scenario, we are calling that as a combination, and the way we are writing it is 10C3, wherein up to here it's that same 10 factorial, 10 minus 3 factorial, whereas here we also have something extra which is the 3 factorial. So which is nothing but, probably people also write it as 10p3 or NPR divided by R factorial. This is the relationship that is existing between a permutation and a combination. In a combination, so in this example itself, we are having 720 divided by 6. So there are only 120 possible combinations for our example. And in each combination, you can have 6 different orders. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. All, if the ranking is important, for each one there is a 6, for each 3 items which I am choosing, there are 6 ways in which they can be ranked. So that's the reason, though there are 120 combinations of 3 stocks, when the order is mattering, I can arrange them in, each one can be arranged in 6 different ways, which means overall it is working out to 720 different number of ways. So in our examples also, how many stocks I need to select out of 50 stocks that are available to me, in how many ways I can select 5 stocks to form a portfolio combination. But if I am more interested in ranking of the stock performances, in how many ways I can rank the 5 stocks, because see, from there again I will derive the probability. What is the chance that this particular stock comes in the top rank out of the 5 ranked stocks? Or probably what is the chance, or probably if I say, if it is ranked 1, give 20 points. If it is ranked 2, give 18 points. Something like that, if I have such kind of scenario. And I have to find out the probabilities at each of the scenario. Then I need a permutation itself, because ranking also matters for me there. But if I am talking about just a selection of 5 to create a portfolio or something, then a combination is sufficient for me. Number of combinations will be much lesser. The third scenario is labeling, especially if I am allotting different numbers to different groups. Like, okay, 2 people or 2 stocks need to be classified as extraordinary. 6 stocks should be classified as moderate, and 2 stocks should be classified as poor. Out of the 10 stocks which I am taking on a random basis, right, out of the 10 stocks, if I want to say 2 will go into extraordinary, 5 will go into moderate, and the remaining 3 will go into worst performing. In how many ways I can do that? So which is nothing but allotting to various groups. The whole n number of items, I am creating some x number of groups and allotting different numbers to different groups. That, how many ways I can do that, is what is accomplished through my labeling or a multinomial kind of a formula. Simple thing is, the same example I talked about, the 10 items, so 10 factorial, depending on what is the group size. One group consists of 2 elements. The other group consists of 5 elements. The other group consists of 3 elements, which can be done in these many ways. 10 factorial by 2 factorial into 5 factorial into 3 factorial. So any number, if it is getting split into x number of groups, where each group has some number of elements, the simple number of ways of allotting the whole n numbers into the different groups goes with the labeling formula, which is the number of items in each of the group. And make sure that the number of items which are being considered, the total number will be equal to the total number of items itself. But yeah, if the group size is 1, 1, 1, we don't even prefer writing 1, 1, 1 here, because 1 factorial is always 1 itself. So, but in a literal sense, if everything is not 1, above 1, make sure that the summation should be equal to the total number itself. So just like some of the things here, the above one is a better example. Supervisor is evaluating 10 subordinates. So for every 10, 2 must be in the exceed expectations, 7 must be in the meet expectations, and 1 in the doesn't meet. Number of ways, labeling. So you are directly going with 10% divided by 10 factorial divided by 2 factorial into 7 factorial into 1 factorial. 3 groups. These are the members of each of the 3 groups. A firm wants to select a team of 5 from a group of 10. So just selection, combination, 10C5 ways. So again, the comfort should be there in terms of which of these 3 formulas that needs to be chosen. Why these things are coming up here? When we talk about, again, probability, see, if there are 10 items, I don't know how many outcomes are possible. Right? If there are only 2 tosses of heads or 2 tosses of 2 throws of dice or something, the number of outcomes is something which is easily known. But if I have 10 items and I have to pick up 3 at a time, and now the question will be asked, what is the probability that one particular item is there in that 10 in that 3 always? Those kind of things could be there. What is the chance of including one particular stock always if 3 have to be taken up from a group of 10? So I need to know how many possibilities are there first of all. So how many possibilities are there? Only when I know that, I can talk about these kind of questions. So in the probability, the total outcomes computation require the formulas like NPR, NCR kind of stuff. That's the reason we are introduced to those spaces just as one single learning outcome for us, right?